Welcome to ArchiCraft, a bit of architect, your go-to podcast for modern software and solution architecture, enterprise strategies, and AI-powered engineering. Each episode is AI narrated, based on the original blog content by Dmytro Golodiuk at Dmytro.com.
You're listening to the 10th episode of the podcast. This episode is titled Model Context Protocol, Bridging LLMs to Enterprise Data. In this episode, we discover the Model Context Protocol, an open standard designed to solve the critical challenge of connecting large language models with chaotic enterprise data systems. We discuss how MCP acts as a universal bridge for AI, using a detailed business case in financial reporting, XBRL, to illustrate how complex real-world workflows can be automated securely and efficiently. Ultimately, we provide architects with a clear blueprint for using MCP to build a new generation of governable, composable, and truly intelligent enterprise applications. Let's get started.
Welcome back to the Deep Dive. Today, we're really digging into something important for enterprise AI. It's all about how to actually get large language models, LLMs, to play nicely with your company's unique, often kind of chaotic data. You've probably heard all the buzz, but maybe also face the messy reality of trying to integrate them.
Absolutely. It's a challenge that definitely keeps senior architects, CIOs, CTOs up at night. How do you securely, reliably, and efficiently connect these powerful LLMs to that vast ocean of information locked away in your enterprise systems? It's about more than just raw data access. It's making that access intelligent, governable, and frankly, safe.
And to help us navigate this, we're diving into a fascinating piece by Dmytro Golodiuk, or Dima, called Model Context Protocol, MCP, Bridging LLMs to Enterprise Data. And this isn't just theory, right? It proposes a concrete, open standard, something designed to be a true game changer, tackling those really stubborn integration and governance hurdles that have plagued enterprise AI from day one. Get ready to maybe rethink how AI can transform things, from financial reporting all the way down to everyday data tasks. So let's maybe start by painting a picture of the problem itself. Dima opened this article with what seems like a simple business question. Something like, what was our total Q3 spend with vendors for Project ABC? And did any of those invoices have non-standard payment terms? Sounds straightforward enough.
Yeah, in theory, yes. But in reality, that simple question often kicks off what Dima calls an archaeological expedition. You're logging into an ERP system for payment data, then you're navigating a separate document management system for PDFs, maybe sifting through shared drives for contracts, sometimes even trawling email archives. It just highlights a fundamental truth. Enterprise data is, a chaotic maze, silos, fragmentation, unstructured formats everywhere. We're talking, 80–90% of all new enterprise data is basically unstructured, locked away in forms that are incredibly difficult for humans, let alone AI, to really manage or analyze systematically.
And into this chaos come these large language models, promising amazing language, understanding, reasoning, task automation. But here's the paradox, right? Their incredible power often gets blunted by their own limitations, and those limitations just get magnified in a corporate IT environment.
Exactly. Take the knowledge cutoff and context window, for instance, LLMs. They're trained on massive but static public data sets. They simply don't know your company's proprietary operations, your latest sales figures, internal policies, nothing specific. Plus, their context window, that's the amount of info they can process at once. It's still, a mere thimble compared to the terabytes of data in a typical enterprise. It stops them seeing the full picture needed for really meaningful analysis.
And then there's the one everyone worries about, the hallucination risk. For something critical like financial reporting or legal contracts, sensitive customer data, accuracy isn't just nice to have, it's absolutely non-negotiable. A plausible-sounding answer that's actually wrong. That's not just an annoyance, it's a potential catastrophe. Serious financial or regulatory consequences.
Which leads directly to the integration nightmare, connecting an LM to your ERPs, your CRMs, maybe some legacy databases. Right now, that means building bespoke, often brittle, and frankly, insecure custom code for every single interaction. Dima calls this the NXM problem. Got N models and M data sources. You're looking at N times M custom adapters. It's just this patchwork of one-off solutions. It becomes an impossible maintenance burden and a real security headache, too.
Okay, and finally, the security and governance black hole, the sort of black box nature of many LLMs creates a fundamental challenge here. How do you give an LLM access to, say, sensitive financial data without just giving it the keys to the kingdom? And how can its actions possibly be audited to satisfy regulators like the SEC or even just your internal compliance teams? Without clear, verifiable answers, deploying these things in regulated industries feels incredibly high risk, like a compliance nightmare waiting to happen.
Yeah, the core of the problem, as Dima really articulates well, isn't just about the LLMs themselves. It's the collision. It's their architectural limitations hitting the pre-existing chaos of enterprise data management, that context window constraint. It goes from being a theoretical limit to a practical disaster when the data you need is scattered across 1,000 SharePoint sites or locked-in unversioned PDF contracts. It's this vicious cycle, and it really demands a more fundamental protocol-level solution, going beyond just layering on more ARAG pipelines.
Okay, this is where Dima's work gets really exciting. He uses this fantastic analogy that helps it click, the USB-C moment for AI. Think about how USB-C simplified connecting electronics with an open standard. MCP, the Model Context Protocol, aims to be that USB-C for AI. Like a universal remote for your AI applications, simplifying how they interact with your entire enterprise ecosystem.
That analogy is key, I think, because it clarifies what MCP is not. It's not another AI model. It's not some proprietary platform you have to buy into. Instead, it's an open protocol, a shared language, basically, a set of rules for communication that standardizes how applications provide context to LLMs. This means any MCP-compliant app can, in theory, seamlessly connect with any MCP-compliant data source or tool. It fosters genuine interoperability. That's the big deal.
Let's actually look at the difference this makes. Maybe compare workflows. Take that fuzzy search scenario we mentioned earlier. A clerk manually sifting through ERPs, document systems, shared drives, just to find related info. With MCP, you just ask an AI assistant that's integrated with an MCP client. The LLM dynamically figures out the right questions, executes a precise search across multiple systems at once, and gives you back a unified, maybe even summarized list of results. No more manual hunting.
Exactly. Or think about document conversion, the classic example. A clerk manually retyping data from a PDF invoice into SAP or maybe Oracle NetSuite. Slow, tedious, super error-prone. With MCT, you give the PDF to your AI assistant. The LLM first uses a, let's say, document conversion tool from some specialized service to understand the PDF. Then it discovers and calls an invoice creation tool directly within your ERP system. It extracts the data intelligently, and crucially, you get a clear dialog box popping up. Create invoice for XYZ Corp for $15,250. You just click approve, cuts down manual effort, slashes errors, but keeps the human firmly in the loop for the actual action.
Okay, that makes sense. And what about data aggregation and analysis? The analysts exporting CSVs from Salesforce, NetSuite, then manually cleaning, merging in a spreadsheet? We've all been there. With MCP, you ask in plain language, compare last quarter's sales from Salesforce with current inventory levels from NetSuite for product line X.
Right. The LLM pulls live data from both systems using MCP resources. It performs the comparison, generates a concise summary with key insights, and could even use a send report tool from an email server to automatically email the findings to management. All in seconds using current data, not stale exports.
Wow, okay. This isn't just tweaking things. It feels like it fundamentally changes how humans and computers work together in the enterprise.
It absolutely does. It shifts the huge burden of integration away from brittle, custom code and endless human hours onto a standardized, intelligent protocol.
So what does this all mean for, you listening? The enterprise architect, the leader who actually needs to make this stuff work. MCP seems to deliver several core advantages. First, standardized integration. That just kills the MM connector nightmare, right? You define tools and resources once, and any compliant LLM can potentially use them. That drastically simplifies your architecture.
Yes, and that standardization enables richer AI workflows. AI agents can perform real actions by calling specific tools. We move way beyond static RAG, retrieval augmented generation. We get dynamic, multi-step tasks that can actually interact with and change the state of your enterprise systems, not just talk about them.
And it provides context efficiency. That's a big one. Because the AI can request specific information on demand, it solves that context window limitation. The model never has to ingest terabytes of reports. It just asks for the precise fields it needs for this query.
And critically important for compliance. Audit and traceability are baked in. Every MCP call can carry metadata, so every answer can cite its source. If an AI reports a financial ratio, the server can tell you exactly which line items and reporting period were used. That gives you crucial transparency and accountability.
And finally, vendor neutrality. Because it's built on open JSON RPC, MCP works with any LLM, any data source SQL, NoSQL, REST APIs, even wrapping legacy systems. That flexibility is incredibly powerful for real-world enterprises with existing investments.
So to really get how MCP pulls this off, let's peek under the hood a bit. It's built on a familiar host-client-server model. Your host application, like a chat interface, maybe an IDE, uses an MCP client. That client talks to one or more MCP servers, which expose your backend systems, databases, applications, etc., and all that communication. It happens over standard JSON RPC. Pretty straightforward stuff, technically.
But what sounds fascinating is the core design principle you mentioned. Delegated trust with the human-in-the-loop verification. Unlike traditional APIs with static trust, MCP pushes final decision-making to the human user via the client. How does that specifically address those big enterprise fears about AI? Loss of control, explainability, auditability.
It's absolutely central to the design. On the server side, capabilities are exposed through three main building blocks. First, resources. Think of these as the nouns. It's how a server exposes data for an LLM to consume as context. They can be direct, like a fixed URI, maybe a specific PDF file path. Or, much more powerfully, they can be resource templates with parameters, like erp.invoices, custored.statuspaid. This basically turns a static data source into a dynamic, searchable API. The LLM can query for precisely filtered information.
Okay, resources are the data nouns. What about actions?
Those are tools, the verbs, how a server exposes actions for an LLM to request. Each tool has a defined schema: name, purpose, required inputs, expected outputs, makes them discoverable, self-documenting. But here's the critical security piece. An LLM cannot execute a tool by itself. It can only request the tool be called. The MCP client must present this request to the human user, usually in a dialog box, for explicit approval. This guarantees any action that changes data, costs money, or has external effects is explicitly sanctioned by a human. Every single time.
Got it. Resources are nouns, tools are verbs requiring approval. What else?
And finally, prompts. These are like prepackaged recipes for interaction defined by the server author. They guide the user towards common, high-value workflows. For instance, a travel server might offer a planned vacation prompt. That prompt would guide the user to provide destination, budget, interests, making sure the LLM gets the necessary info for a complex task efficiently.
Okay, that's the server side. What about the client side? What does the MCP client provide?
The client acts as your trusted agent, offering powerful features, like roots. It sounds simple, but it's a crucial security primitive. When interacting with, say, a file system, you specify root directories via the client, like file.users geneproject-alpha. You're telling the server you are only allowed to operate within these specific boundaries. No roaming around. It enforces the principle of least privilege right there at the interaction level.
That makes sense.
Yeah.
What else?
Then there's elicitation. This is, I think, a game changer for usability. It solves ambiguity on the fly. Let's say a server needs more info to proceed. Maybe a tool call is missing a parameter, or a search query returns two customers with the same name. Instead of just failing, the server sends an elicitation request back to the client. You, the user, get a structured question. Which XYZ Corp entity do you mean? Option A, option B. It turns potential workflow failures into simple, interactive clarifications, makes the whole system much more robust and user-friendly.
Okay, I like that. Elicitation for ambiguity. What was the last one? Sampling.
Right, sampling. Think of this as the secure phone-a-friend for AI tasks. A server can ask your client's LLM to perform an AI-dependent task. Things like, summarize this document or translate this email, but the server does this without needing its own AI model, its own API keys, or its own billing relationship. The security implications are huge. First, isolation. The server gets no access to your main chat history. Second, user consent. The client must show you exactly what the server wants to analyze and why. You have to explicitly approve before the request even goes to the LLM, and you review the AI's response before it goes back. This delegated AI keeps you in complete control.
Wow, okay, so combining resources, tools with approval, elicitation, roots, and sampling.
Exactly. MCP ensures an LLM can propose complex workflows, maybe even involving multiple steps and systems. But every single step that mutates data or interacts externally is discrete, auditable, and requires that explicit human thumbs up. It's just a fundamentally more secure and governable way to think about enterprise AI. Really moves past that scary black box problem.
Okay, theory is great, but to really see the power, we need a properly difficult enterprise problem. Dima, with his background in regtech and subtech, points to XBRL. That's the Extensible Business Reporting Language. He uses it as a perfect example of a complex domain where this approach could really shine. What makes XBRL such a beast?
Oh, XBRL. It's the global standard for digital business reporting, mandated by regulators like the SEC here in the US, ESMA in Europe. Now, it's meant to make financial data consistent and machine-readable, which sounds great, but implementing it's notoriously complex and incredibly error-prone. The core challenge is something called tagging mapping human financial concepts, like net revenue, to the correct digital tag within a vast hierarchical taxonomy. The US GAAP taxonomy alone has over 17,000 distinct concepts. It's easy to get lost.
And that complexity leads to real errors, right? Dima mentioned specific types.
Yeah, he highlights things like invalid member access combinations. That's basically miscategorizing a financial concept. Apparently, that accounts for over a third of errors. And negative value errors, where a value that should be positive, like revenue, gets entered as negative. Another big chunk, around 12%.
And existing AI tools trying to help often act as black boxes, making mistakes, lacking explainability, which auditors and investors hate.
Precisely. It undermines trust. So how does MCP change this specific game?
Right. How does an MCP-based architecture tackle this XBRL mess?
It completely flips the script. It transforms XBRL reporting from this arcane technical task into more of a collaborative conversational workflow. An analyst interacts with an intelligent assistant. You could ask natural language questions like, compare the liquidity ratios of these companies over the past year and get immediate accurate answers grounded in the official XBRL data without having to wrestle with complex XBRL tools directly.
So how does the XBRL compliance server use those MCP primitives we talked about, like for
Right.
tagging?
Good question. First, taxonomies as resources. The server exposes the entire XBRL taxonomy, not as some static file download, but as a dynamic, queryable resource. So the analyst asks, what's the right tag for revenue we recognize over the life of a customer subscription? The LLM uses a resource template, maybe something like xbrl.taxonomistgap concept description, searches the taxonomy, and presents the top options with official descriptions. It empowers the analyst to make an informed choice, rather than guessing or spending hours searching dense documentation.
Okay, that helps find the right tag. But what about preventing those errors, like the negative value one?
That's where solving ambiguity with elicitation is perfect. Let's say you try to tag common stock value, which should usually be positive, with a negative number. The apply tag tool on the server detects this mismatch based on taxonomy rules. It then triggers an elicitation request right back to your client. Hold on. Common stock value is typically positive. You provided a negative value. Did you mean to apply a negated label to flip the sign for presentation? Triffins. See, it turns a frequent critical error into a simple interactive clarification at the point of entry. It's designing the error out of the process.
That's clever. And for a final check, maybe before filing.
Exactly. Human oversight via sampling. You could have, say, an audit filing prompt. The XBRL server would use sampling to securely send the context of the entire filing over to your client's powerful LLM. The instruction might be something like, act as a senior financial auditor. Review this XBRL filing. Look for potential inconsistencies, logical errors, or deviations from standard accounting principles. The LLM provides its AI-powered analysis, but, and this is key, its findings are presented back to you, the human analyst, for final review and sign-off. You maintain a clear audit trail and ultimate human accountability.
So this approach directly hits the biggest XBRL pain points. It prevents common errors, builds trust.
Exactly. And the fact that there are already open source projects popping up, like an SEC ADJAR MCP server that can query official filings, it really shows this model isn't just a nice idea, it's practical and being implemented today.
Okay, so realizing this promise requires a smart integration strategy, especially in complex enterprise environments. Can't just flip a switch. How do you actually weave MCP into an existing IT fabric pragmatically?
Yeah, you definitely need a plan. Dima emphasizes using proven enterprise integration patterns. First, the API gateway pattern makes total sense. In a large company, you'll have lots of MCP servers, ERP, CRM, HR, maybe custom ones. An API gateway like AWS API Gateway, Azure API Management, whatever you use, acts as that single unified entry point for all MCP traffic. It handles the crucial stuff: authentication, authorization, rate limiting, centralized logging. Gives you control and visibility.
Right, the gateway is the front door. What about older systems, the ones you can't easily change?
That's where the adapter pattern comes in. Enterprises are full of legacy systems, right? On-prem databases, old apps. An MCP server can act as an adapter. It wraps the old system's non-standard interface, so it translates modern MCP tool calls, like get customer record 123, into whatever weird format the old system understands. This unlocks valuable data and functionality from those legacy systems without a risky, expensive modernization project. You're bridging the old and new.
Makes sense.
Yeah.
Gateway for control, adapter for legacy. Any others?
And the event-driven pub-sub pattern. Not every AI workflow needs a human clicking buttons in real time. Think about high-volume automated tasks. Maybe a new invoice PDF lands in cloud storage. That event could trigger a serverless function which acts as an MCP client. It kicks off a workflow using relevant MCP servers to process the invoice, maybe extract data, create a draft entry, all without direct human interaction initially. Great for background processing.
Okay, those are the technical patterns. But adoption also means winning over the CISO, right? Security and governance are huge. How does MCP's design help build that trust and provide a robust governance framework specifically for AI behavior?
It provides hooks for exactly that at the application layer for AI. For instance, it directly supports the principle of least privilege, POLP, those roots we mentioned. They restrict file system access to sandboxes. And tools expose only specific approved business functions, not the whole underlying system API. An LLM simply cannot call an undocumented or unauthorized function via MCP. It's also designed to work naturally with role-based access control, RBAC. You'd enforce that at the API gateway, probably using standard OAuth flows. So users in finance can access the ERP server tools, sales users get the CRM server tools, and so on. Standard enterprise practice.
And that auditability you mentioned earlier is key for governance too.
Absolutely critical. Auditing and traceability are built-in possibilities. Every single call to a data mutating tool can be logged with rich metadata: who requested it, what parameters were used when it happened, and crucially, evidence of that explicit user approval. That level of traceability is gold for compliance folks worried about GDPR, SOX, etc.
So the human in the loop isn't just a workflow feature, it's actually a core security control.
You got it. By making human approval a first-class citizen of the protocol through tool approval, elicitation responses, sampling consent MCP provides the ultimate backstop. It's a defense against runaway AI agents or accidental misuse. Governance isn't just about static permissions on data, it's about real-time, context-aware permission for actions.
Okay, so putting it all together, what's a pragmatic adoption strategy look like for an enterprise leader listening to this?
Dima suggests a phased approach, which makes sense. Phase 1, start small. Identify a high-value but low-risk use case. Focus initially on read-only operations, like that fuzzy search example. The goal here is just demonstrate the power of unified data access. Build some enthusiasm without touching critical production data yet. Show value quickly.
Okay, prove read-only value first. Then what? Phase 2.
Phase 2. Introduce action-oriented tools, but carefully. Select a workflow with clear ROI. Maybe that XBRL tagging assist or the PDF to ERP invoice creation. But crucially, secure that workflow. Implement proper OAuth scopes, require explicit user consent for any sensitive operations. Now you're showing direct business value, but with controlled, auditable risk.
Makes sense. Start safe, add actions carefully. What's phase 3?
Phase 3, scale and federate. This is where you really build it out. Establish a center of excellence, maybe?
No.
Put your core MCP servers behind that central API gateway for consistent governance, and then encourage the development of multiple client applications tailored to different user groups or tasks. This fosters that truly composable, interoperable enterprise. Innovation can happen at the edges while control stays centralized.
Wow. This deep dive really feels like it connects the dots. We started with that paradox: powerful LLMs hitting the messy reality of enterprise data, a world of brittle, custom integrations that just isn't sustainable.
Exactly. And we've seen how MCP, the Model Context Protocol, by establishing an open standard language, moves way beyond just fixing integration point to point.
Yeah.
Its whole architecture, built on that delegated trust with human-in-the-loop verification, gives you the technical building blocks for applications that aren't just intelligent, but are also inherently more secure, governable, and transparent than what we have today.
For the everyday analyst, it turns tedious tasks like searching or merging data into simple conversational requests. For the finance pro, it changes complex XBRL reporting from a nightmare into a guided workflow that actively prevents common errors. And for you, the architect, or CIO, it offers a clear blueprint for adoption and, crucially, for robust governance over AI actions.
Ultimately, the vision MCP points towards is enabling a fundamentally new architectural paradigm, what you might call the composable AI-native enterprise. Your enterprise capabilities, getting estimate data, creating an invoice, checking inventory, they're no longer locked away inside monolithic applications. They get exposed as discrete, intelligent, and interoperable services that can be dynamically combined.
So LLMs become the orchestrating brains of this new enterprise.
Right. And MCP provides the secure central nervous system. It allows those brains to safely and effectively interact with your enterprise's hands and eyes, all its diverse tools and data sources. As Dima puts it, this creates a space where both major enterprises and individual contributors can build equally viable, increasingly valuable options to make everyone's lives better.
That really opens up possibilities.
It paves the way for a future where complex business processes aren't rigidly coded years in advance. Instead, they're dynamically assembled, optimized, maybe even executed in a continuous, intelligent conversation between humans and their AI counterparts. For organizations ready to embrace this kind of model, the potential competitive advantage feels immense.
That is definitely a powerful thought to mull over as you think about your next enterprise AI project.
Nice.
Thank you so much for joining us on this deep dive. We really hope this has sparked your curiosity and giving you some valuable insights into bridging LLMs to your enterprise data safely and effectively.
Thanks for tuning in to ArchiCraft. This episode was generated using AI from Dmytro Golodiuk's blog at demongo.com/news. If you enjoyed this episode, follow the show on your favorite platform and share it with fellow architects and engineers. Until next time, build smart, architect with intent.